Hello everyone, welcome back to MindMatrix YouTube channel, and here we are with the most demanded video uh, from GATE DA experience for 2024 exam. So in this video I'll be solving questions which were given in GATE DA sample paper. Okay, so as you know, like there are a good number of questions, which is like around 55 questions in GATE DA sample paper. So what we are going to do is we are going to divide the solution into a number of videos, and per video you'll be getting nearly 5 to 7 questions. Okay, so this is going to be the first video. That was the first point. Second point is the order may not be the same what we are having in the original paper. Okay, so that order can differ over here, and now I'll be starting with the solutions. Okay, so let's begin. So this is a brief intro about myself. I'm upcoming data scientist at Lowe's India. Qualification is MTech AI, IISc Bangalore. I'm finally a student. I have already like 3+ years of experience, mentored more than 1,000 students, expertise in data science and machine learning subjects. I already had AIR 70 GATE CS exam in 2020. And you can just, like these are the other achievements I'm having. You can see that. Okay. So let's move further. So today, which is like 20th of January, is the last date for the offer to avail. This is the first offer we are having over here. So you can see the prices we are having. So before midnight, you can enroll if you are watching it on 20th of January. Okay. So let's move further. And one more thing is for GATE Computer Science, operating system is going to be offered for free. Okay, as a contribution towards the students, because like most of the students look for some kind of subjects, and OS is one of those subjects which is a bit complicated, so you don't really get this for free. Okay, so that's why that is our contribution for the students. Okay, so it is also starting from tomorrow, that is 21st of January. Okay, which is Sunday. So tomorrow it will be starting. You can just register for free on our website, which is www.mindmatrix.net.in, which is mentioned in the like lower portion of our PPT as well. Okay. So you can visit our website, join our social media channel and groups for discussion and updates. So I have created, QR codes for everything over here. Just scan and you'll be able to reach wherever you want with respect to our channel, group and website. Okay, first way is for website, just scan it and it will land you on our website. Second is for Telegram group, you can join there, and third is for WhatsApp channel we are having. Okay, so let's start with the questions now. So the first question, so the question says, given three literals, yes, one more thing over here, as asked by a student in our Telegram group, I will be assuming, because that was the reason I was delaying the questions every time. That was the reason I was not coming up with the solutions. That there is not enough of background, not many videos with respect to the GATE preparation and course content. So I'll be assuming over here that at least some good basics around the topics on which questions are being asked. Okay. For the solution, whatever is required, I'll be telling, but still I would assume that some basic, because that was required. If you don't know, like it may be difficult, so just you have to bear with that. Okay, so given three literals, basically the variable over here are being mentioned with the literals. Okay, okay, three literals A, B and C. Okay, mentioned over here. What is being asked? The number of models for the sentence A, or negation of B or C. The expression is exactly A or negation of B or C. So this is the expression we are having. Okay, this is the sentence we are having, and these are the literals. If I just talk in terms of what preposition, so this is like a compound preposition we are having, for which these individual ones are atomic prepositions. Okay, so if I talk about, just to simplify over here, A can be anything from true or false. Okay, value of A, which is a preposition, something like, okay, A can be something like sun rises in the east. So that's a true statement. Okay, or if somebody asks you, okay, something like, okay, every student scores above 90. Is that true or false? So something like this. Okay, so we will be having either true value or false value. any proposition cannot have both the values altogether. Okay, there are some principles which we will be discussing when we will be starting somewhere in the future about this topic. Okay, but over here you can just understand that our proposition, or basically the literal we are having over here, can have only one of these values, true or false. Similarly for B and C. Now if I talk about the number of models, so what exactly is a model? Model is value for which value of literals or atomic proposition for which our sentence is true. Just as a brief, like I'll be giving you some short overview about the things being involved, which for which our sentence is true. This is important. Okay, the values for which A or negation of B or C will be true. Okay, so the value for literals, the value of literals. So just tell me how many numbers of models can be there. So the number of models will depend upon number of values A, B, C can have, such that the entire sentence becomes true. The entire sentence becomes true. That will become my model. So if I just talk about, let's take an example. So if my A is true, B is true. I'm just taking an example. C is true. What is the truth value of this sentence? Just tell me. True or negation of true or true. What is this? It is true or false or true. And like for the or operator, if at least one is true, the answer is going to be true. The answer is going to be true. Yes or no? So up till this point, it is clear. So this is one of the model. This is one of the model. Other model can be something like, if I say false, false, true. Let's suppose this. That means the value of A is false, the value of B is false, and the value of C is true. If I just consider that, for that also this will coming out to be true. That means this is also a model. So what will be the number of models? The number of models will be for whatever values we can have, my final truth value is coming out to be true. That is going to be my model over here. Okay, in simple words. So now just tell me that when can it be false? Because one way for finding number of models is I need to look for each of the case when it is going to be true. The other point can be when it is not false. Yes or no? Both the things are same. One way is finding out when it can be true, what all cases are there when it can be true, or just find out total number of ways it can have a true or false value, and then subtract from that number of ways in which it can be false. Yes or no? Total ways minus false cases will also give me total ways in which it can be true. One and the same thing. So I'll be following this path. Okay, because there exists only one case for false. Why so? Because you already know that if I just consider, okay, this is A or negation of B or C. So let's say this is P. Let's say this is P. So just tell me, if A union P, sorry, I'm again saying union because like or over here and insect theory union, those are kind of like similar thing. Okay, A or P or C. Just tell me when this is going to be false. Just think about this. Always remember, in case of or, okay, if we join the prepositions or literals with the or operator, then when can it be false? Only in one case, when each of them is false. When each of them is false, then only it is going to be false. If at least one of them is true, then the entire value is going to be the proposition the truth value of the entire sentence or proposition is going to be true in that case. So this. Basically, when this will be F, this will be F, this will be F, only then it is going to be false. Yes or no? Only then this is going to be false. Okay, this is clear. So that means I am saying when A is equal to false, which is same, P is false. That means negation of P must be true. I hope this is very simple. If P is false, then P was negation of P. So P has to be true. And C is false. Only in this case, my value of this sentence is going to be false. I hope this is clear. And how many total ways can be there to get a true or false value of this?
How many total ways are there in which we can have a true value or false? Basically, just think about this. What are the possibilities for a value? Two only. Either true or false. That means two choices for this. What are the choices for B? We are having only two choices. True or false. Again, two choices. What about C? Again, two choices. True or false. So in total, if I just talk about how many combination of true, false, true, whatever, like for A, B, C, if I just talk about true, false, true, false, true, false, placing for each of A, B, and C. If I just place. So total, how many combinations can be there? 2 into 2 into 2. That is 8. Yes or no? Just think about that. So in total, in 8 ways I can combine, sorry, not combine, combination is already there. There are total 8 ways in which I can have input to my sentence. That my A can be true or false, B can be true or false, C can be true or false. Like I just mentioned, this is one of those cases. Or it can be like T, F, T. You can just write that, as we write. If I just simply remove this and, start writing from first case when all are false, then false, false, true, then false, true, false, and something like this. If we go on, we'll get total 8 inputs, and for each input I'll be having some output, and out of those output only one case will be there when it is going to be false, and we have seen that is going to be this particular one. So that means how many models are there? We had total 8 ways we can have the input. That means 8 interpretations we are having. Out of that, only one case exists where it will be false. That means the number of models. What is the model? When I have truth, when we have the truth value as true for the sentence. So that is going to be 7. I hope this is clear. Total cases minus the false case. Okay. And model is always sorry, yeah. So we have a model when we have true as the final truth value of my proposition or the sentence. I hope the idea is clear. As I mentioned, so there are like a lot of prerequisite, but I'm just trying my best to explain it in a simpler way. Okay. So I hope I have cleared everything over here, whatever was required. Okay. So 7 is the final answer for this. Okay. So let's move further now. Again, a simple question on the statistics over here. So the mean of the observation of first 50, I hope you have done this. This was very simple. Okay. The mean of the first 50 observation of a process is 12. Something like this I can write. X bar 50. X bar means I'm talking about the mean and of 50 observations. X 50 means like 50 means 50 observation, and X bar means I'm talking about the mean. Okay. So this is given to be 12. Okay. And you know the formula for this one as well. What exactly is to, way of calculating this is going to be sigma xi upon 50. Okay. I hope this is clear. I is equal to 1 to 50. Basically, add all the values of x from 1 to 50 and divide it by 50. That will give me the mean. I hope this idea is clear. Yes or no? I hope it must be clear. I don't know, because if it would have been a live class, then we would have enjoyed it. Now, if the 51st observation is 18, that means x51 is given to be 18, then the mean of first 51 observation of the process, we need to calculate this. We need to calculate this. What will it be? It is going to be like this. I is equal to 1 to 51 upon 51. Yes or no? Now, it's very simple. Okay, you can just use basic mathematics. It's like an aptitude question you are having. So I can simply write it like this. Just think about this. Okay, I can just break it up. So this is from I is equal to 1 to 50. Basically, I can break it into the two form. Like one is sum from 1 to 50 observations, and then x51. Yes or no? Yes or no? Very simple. I hope you'll be getting this, and divide by this. Okay. Now, if I just talk about this thing. Okay. So what is going to be this? What is going to be this? You can just think about this. The summation for 50th term is equal to x bar of 50 into 50. Yes or no? I hope this is again very simple case over here. So this is going to be 50 times of
whatever was the sum, sorry, 50 times of whatever was the mean for 50 terms. What was that? That was 12. So into 12 plus what else? X51 is given to be 18 divided by 51. Okay, so this is 12 into, just calculate this, plus 18 by 51. Okay, like I have broken down, you can just calculate the way you want. Okay, and this way you'll be getting a final answer. Okay, I hope I need not find it. Answer is going to be very simple over here. Okay, you can just calculate with the help of a calculator and you'll get the value. The point is, how do we solve it? And I hope you have got this idea. Okay, one of them is going to be the answer and it will be matching. The only thing I remember is, while calculating, I don't exactly have the answer, but I still remember one part. It is going to be 12 point something something, and then there was something like above 5 was there, I guess 7 or 8 was there. Okay, so when you just remove that, you'll increase this value by 1. Okay, I hope you know the rounding of rules. Okay, so for an example, if it would have been 12.356, so if I'm just removing this, I'll just add 1 over here, so answer in that case will be 12.36. Like if I'm not wrong, I can just recall that maybe this was the answer. You can just calculate it. Okay, you'll be getting the final value. Okay, so I hope I have cleared the round of answer as well over here. Okay, so let's move further for the next question. A fair point. So I have already solved this question in my probability playlist. I hope you can go and check out the concepts over there as well, because I have covered the basics of Bayes theorem. Whatever was required, we have already done that. Okay, so I still will solve this question over here. A fair coin is flipped twice. Okay, a fair coin is flipped twice. So like what all possibilities are there. So it is going to be, I'm again writing false. It is going to be something like this: tail, 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 head, head, tail, and head, head. Okay, this is going to be the possibilities. If I consider it to be the first one's, what should I say? Face, and second one's face after flipping. Okay, so what it means that, okay, when I flipped for the first time, it may be a case that I got tail or a head, and when I flipped for the second time, again it can be tail or a head. So depending upon that, I can have these 4 combinations. Okay, now it is given that at least one tail has been observed. Okay, so let's consider this to be an event that, okay, I'm already told that A is one tail has been observed. So just tell me, at least one tail has been observed. So what all cases can be included over here? It will be tail, tail, head, tail, and tail, head. Yes or no? Very simple. You can check out my playlist over there. It is like clearly I have shown you how to get all these things. What exactly is an event? I have solved this already. Okay, so this is going to be A event, which is this one only. Now this has been observed. Now probability of getting 2 tails. Now B is exactly, B is getting 2 tails. So B is going to be, I'm talking about tail, tail. Okay, B event is tail, tail. Now what do I need to calculate? I need to calculate probability of getting B event given A event has been occurred. A event has been occurred. So I have already shown you exactly that okay, what happens in this case. So overall your sample space reduces to A event size. Okay, this is nothing but a kind of measure. Okay, so what you'll do over here, what is it going to be? So I hope you remember this. It will be probability of A intersection B by probability of A. Or what else you can do is, over here, it is going to be the size of your A intersection B event divided by size of A event. Okay, so just tell me, what is it going to be? If I just talk about this thing, A intersection B, what is the probability of that? So that is going to be, A intersection B is going to be tail, tail only. That means only one case is there. And if I talk about the sample space is already written over here. It is tail, tail, head, tail, tail, head, and head, head. Okay, so probability for this thing is going to be 1 by 4. Okay, this is going to be 1 by 4 for A intersection B. For probability of A, it is going to be A intersection B we are talking about. Yes, for this one What is it going to be? Probability of A intersection B only, no? A intersection B upon this thing. So probability of A intersection B is going to be tail only. And for tail, what is, yes, yeah, fine, sorry. And what is probability of A? This is the A event, okay? So we can have these three outputs. So this is going to be 3 by 4. And the answer you get is 1 by 3. Very simple. Or you can go by this measure example we have already learned in our probability playlist, that what is the size of A intersection B? Again, if I take an intersection, what is it going to be? It is going to be the size of B only, which is 1, divided by what is the size of A? It is 3. So answer is 1 by 3 over here, which is this particular one. So the answer is 1 by 3. I hope the idea is clear. You have got this. Okay. It was a simple question. Let's move further. Again, this question also I have solved. Okay. As this includes the basics of counting over here. Okay. So let's find out. So we have n particles. We have n particles. Okay. We have n particles. So this is a kind of problem based on distribution. Oh, particles. And m is number of boxes. M is the number of boxes. We place each particle. We are placing each particle into the box. Okay. Randomly we are just putting it. What is the probability that no box receives more than one particle? Basically what I'm saying is, we are putting it inside the boxes and we won't be putting more than one particle in a box. That's it. That means whatever is going to be the final one, it is going to be something like this, that n boxes has been filled. N boxes, exactly n boxes will be filled. N boxes will be filled. Yes or no? Just think about that. When I talk about the final thing I have done, okay, the event I'm just talking about this. Let's say this is the A event I'm talking about. So A event means exactly n boxes has been filled. Why exactly n? Because in each box, whichever box was there, I have put only one particle within that. So exactly n boxes has been filled. How many total boxes are there? There are total of m boxes. So just think about the sample space, okay? Because for the probability, what do I need to find? We need to find the, size of each one, size of each set. We are having size of each event. So if I talk about the sample space, what is the, size of sample space going to be? In how many ways I can fill m boxes with n particles? In how many ways I can fill my m for mat, okay, m boxes with n particles? Very simple. We have, see, we have n particles, 1, 2, up to m. What is the number of choices for the first particle? In which box it can go? There are m choices. It can go to any of the m box, What is the number of choices for the second particle? Again, m choices. Basically, let's suppose this has gotten into third box. So again, for the second particle, I can put it in any one. It can be the same as the first one. Third box also it can go into, because I'm talking about the total cases. I'm not talking about this case for which I need to calculate the probability. I'm just talking about the total number of cases in which I can put n particles into m boxes. So it can be within the same box as well or in some other box as well. So I have m choices for the second one. For the third one, again, I will be having m choice. Up to how much times? So for each of the n particles, I'll be having m choices. So what is going to be the total number of ways in which I can put it? M to the power n. So the size of my sample space is going to be m to the power n. I hope this first thing is clear. Okay. Now, just think about this. That in what ways, in how many ways I can do this. Okay. If I talk about the A event, in how many ways I can have this exact scenario that I have filled exactly n boxes. So for n boxes, I have to, first of all, it is kind of choosing n boxes out of m and then filling them with our what? Particles, yes or no? So it is going to be like either you can say m p n, that is also fine, or you can say, just choose n boxes out of m. First of all, choose any of those n boxes out of m, and then we can arrange as well, because right now in this question it is being assumed that our boxes are also different and our particles are also different. I hope this is clear. Okay, boxes and particles both are different. Okay, so either you can do this mpn. I have not, like, this is not complete. mpn means permute out of m things, n things you need to permute. Okay, so it is going to be something like this. So basically it is like, okay, I have m boxes, so I have chosen n things to permute, n things only out of these m. So this is going to be similar to mcn into n factorial. How these are same, let me just tell you numerically. I hope you know how you'll be getting this. Okay, numerically, you just open it up and these will be same. Now mpn over here, just think about this, that we are having m places. It's like m places. Let me just show you m places. Okay, and you have already assumed as if you are having these different boxes. Okay, and you had n particles. Okay, you have these ordered. Okay, n particles are already ordered. So what you are doing is, out of these m boxes, you are picking up n and then ordering them. Just think about this. Out of these m, what you are doing is, you are collecting n boxes and then ordering them, and whatever ordered you have fixed, within those you are just placing these one by one. This is equivalent to saying that out of m boxes, I will choose n boxes first, and then in each one of these I can have a permutation for my n particles. Okay, first, for an example, if I have chosen this, something like this, then I have chosen my n boxes, and I had like 1 2 3 up to n. Now the order within these n boxes can be any of those. So there, how many orders can be possible? If I have n things, there is n factorial ways. So mcn into n factorial. I hope you are getting some idea over here as well, but still if it's not clear, it's fine. Okay, mpn means out of n things you are permuting n things. Okay, so a number of ways you can perform a event is this thing or this thing. So what exactly is this? This is m factorial divided by m minus n factorial. Anyway, you can just pick up and you'll get this m factorial divided by m minus n factorial. And when you divide it, basically this is for a. This is the number of, you can say, the number of ways you can perform a event, the number of ways you can have a event. So the size of a is going to be this total number of ways. What is the total number of ways which you have, in which you can have kept these n particles in m boxes, is going to be the total sample space size, which is m to the power n. Just divide it. Probability for a event is going to be what? I can write it in this way now. Yes or no? So what is this? M factorial, m minus n factorial, and then m to the power n, which was the, which is the matching one. I hope. Oh, so there are, yeah, clear. So this is the final answer we are having. B is the final correct answer. I hope the idea is clear. Very simple. So you can just, watch this part again if you don't have any doubt, or you can comment it down. Okay, I'll be answering each and every problem you are having.